Okay, let's take a look and see how you're doing. Both of these are ones that we've seen before we covered them last Thursday even, so hopefully we're doing okay with them now. The first one here, of course, whenever we see parentheses, we do have to ask ourselves if there's anything we can do inside of them. And here there is not. Nothing we can combine in there. So in this case, then, we have to multiply the parentheses by the 7x squared y. And remember, the fancy name for that process is distributing. But it is really just a form of multiplication. So 7x squared times y, or 7x squared y times 8x is going to give us 56 x to the third and y. There we go. 7 times 8 is 56. X squared times x is x to the third, and then just the y. And then the 7x squared y times the negative 11y. Perfect. Negative 77 x squared y squared. 7 times negative 11 is the negative 77. X squared doesn't have anything else, so it's multiplied just the x squared. And y times y is y squared. So there we have it. 56 x to the third y minus 77 x squared y squared. Down here, we had a couple of options. We could use that mnemonic, that shortcut of FOIL, or we could write it out and actually do the long multiplication with it. Either way, we should get the same answer. I'm going to do the shortcut with FOIL right now because in a second, or in a few minutes, it's going to be more helpful to have it that way when we start going backwards. So the F, of course, stood for first. So x times x is x squared. O stood for outside. So the outside digits, x times 2. 2x. There we go. Positive 2x. I stands for inside. So 5 times x is positive 5x. And L stands for last. 5 times 2? Positive 10. So we've got the x squared. That was from our first digit from the F. The outside and the inside combined, 2x and 5x makes 7x. Nope, just adding them. Remember, add them and keep the same name. And then, of course, that last digit, which came from the last digits, is the 10. We're going to come back to this little picture in a little bit. The answer, of course, is x squared plus 7x plus 10. We're going to come back to that picture after a few minutes. I want to go back up to this first one. If I wanted to reverse that process, I would have to look at these two digits here, these two terms of that polynomial, that algebraic number. And I would have to figure out what I could divide out of them. In other words, I would be looking for a greatest common factor for those two digits of 56 x to the third y and 77 x squared y squared. Now remember, the variable part's really simple. The numbers we can find by factoring if we want to. Can anybody look at those and tell me what the greatest common factor of 56 and 77 is? 7 is actually the only number that divides into them. 77 can only be, the factors of 77 are 7 and 11. Those are its only factors. 56 is 2 times 2 times 2 times 7. So the 7 in common is the only common factor. So 7 is the numerical common factor. For the variables, when we do common factor, greatest common factor, It is the smallest power of each variable. Remember, when it's least common denominator or least common multiple, it's the other way around. It's the largest power of each variable. So for x, what's it going to be? X second, right? We got third and the second. The smaller one is 2. For y, just y. Now let's remember why that is. Because x to the third is 3 x's, and then of course y, right? Then the other one's x squared, so x times x, and then y squared is y times y. We're looking at the ones that are in common. There's 2 x's in common, that's x times x is x squared. And there's just a single y in common, that's just the y. So that's why we take the smaller power, because that's the number of times that factor appears in common, is the smaller power. So 7x squared y is the greatest common factor. See a correlation there? So once I've found that greatest common factor of 7x squared y, I have found 7x squared y is my greatest common factor. Remember when we did factor trees? If I was factoring 80, I said 80 is divisible by 10. How did I get the number to go over here? Yeah, 80 divided by 10 left me with 8, right? I divided that original number by that factor I was taking out. I'm going to do the exact same thing over here. I'm going to divide that by the factor I'm taking out. X squared, or 7x squared y, is my factor that I'm dividing out of it. And I want to see what's left over. Just like over here, when I took out the 10, I wanted to see what was left over. I took out a 7x squared y. I want to see what's left over. I'm going to divide. So 56x to the third y divided by 7x squared y. I divide the numbers. What's 56 divided by 7? 8. X to the third divided by x squared? Just x. Y divided by y? Cancels out. Anything divided by itself is 1. So then we got 77x squared y squared divided by 7x squared y. What's negative 77 divided by 7? Negative 11. X squared divided by x squared. Cancels out. Y squared divided by y is just y. Again, that should look somewhat familiar. So what we did here was we just reversed that process of multiplying those together. Just like this was called factoring, this here is also called factoring. And what it is it is called the greatest common factor method. So you are looking at an algebraic number or a polynomial, and you are finding the greatest common factor, and then you are dividing it out. And that greatest common factor, the GCF method, is always the first thing you will look for when you are asked to factor something. So if I ask you to factor something like 60x to the 7th, y to the 3rd, plus 77x to the 5th, y to the 5th. First thing we need to do is find the greatest common factor of the numbers for 60 and 75. If I factor 60, what's one number that goes into 60? Well, it ends in 0, right? So 10. 60 divided by 10 will leave us with 6. 10 can be split into 2 and 5. Both those are prime. 6, 2 and 3. Both of those are prime. So this is 2 times 2 times 3 times 5. What's the number 75 can be divided by?
45 and 2.
Careful. It does divide by 5, though, and 15. 5 is prime. 15 would be 3 and 5 again. So 3 times 5 times 5. What do they have in common? They have a 3 and they have a 5. So 3 times 5 is 15. So 15 for the numbers is the greatest common factor. You look confused, Jay.
Oh, you have a 2 plus 2 times 2, and just the 5.
Yep. But we're not looking for least common multiple. We're looking for greatest common factor. Yep. So we have 15 is our greatest common factor for the numbers. What's going to be the power on the x? 5. We're looking for the smaller power when we do GCF. And for y? 3. Very good. So now, 15, x to the 5th, y to the 3rd is going to be one of our factors. We need to find the other factor by dividing out the 15, x to the 5th, y to the 3rd. See what's left over. 60 divided by 15. 4. X to the 7th divided by x to the 5th. X to the 2nd. Good. When we're dividing, remember, variables with exponents, we subtract the powers. Y to the 3rd divided by y to the 3rd goes away. Anything divided by itself disappears. 75 divided by 15. It's a positive 5. Good. X to the 5th divided by x to the 5th goes away. Y to the 5th divided by y to the 3rd. Y squared, y to the 2nd. And that is it. So when we were factoring, and we were trying to find a greatest common factor, first thing is you find a GCF for the numbers. If you remember, the term that they use for those is called the coefficients. To find that, of course, you prime factor them. And you use the common factors. So we're only using the factors that are in common. Just like we did up here. We circled the ones that are in common, the 3 and the 5. When we're doing least common multiple, we're worried about the ones that are left over after we take out the common ones. So, careful. Yeah, the 2 2s and the 5, yeah. And then you use the smallest power. For each variable. Which again is the opposite. For least common multiple, you use the largest power of each variable. So if I ask you to factor, (48) x to the 5th minus 72 x to the 3rd y squared. Tell me what to do. So we have to find the common factors for 48 and 72. Now, some of you, as we go through this process, might get good at just looking at those numbers and figuring out what it is. If you were looking at this if this were in fractions, if that was 48 over 72, you'd be looking at the number you would divide both of them by, right? Well, 48, does anybody see the number for 48 and 72, by the way? 8 won't go into 48. 8 does go into both of them, you're right. But there's a bigger number, if I remember right. Yes, there is. 12 will go in. (48) if we factor, it would be 2, 2, 2, 2, 3. (72) would be 2, 2, 2, 3, 3. So what do they have in common? 3 2s and 1 3. So 2 times 2 times 2 times 3 is 24. A lot of people see 6, 8, or 12. The 24 is a little more elusive. So I'm going to have to divide this by 24. What am I going to use for my x? X to the 3rd. How about y? Careful. This first term, this first digit, doesn't have a y in it, right? So the lowest power of the y is 0 or non-existent. So there is no y in our greatest common factor because it didn't appear in this first digit, in this term here. So now we have to divide it out to see what's left over. 48 divided by 24? 2. X to the 5th divided by x to the 3rd. X to the 2nd. Very good. Now we have negative 72 x to the 3rd y squared divided by 24 x to the 3rd. Negative 72 divided by 24. Negative 3. X to the 3rd divided by x to the 3rd. Cancels out. Y squared is just y squared. Nothing divided out by. We're going to play the what if game for a second here. Notice over here, these two numbers, 2 and 3, are what we call relatively prime. There's no other number that can divide into both of them, right? What if we had used the 8 or the 12 over here? Let's say we did 8x to the 3rd. Well, what is 48 divided by 8? 6x to the 2nd, right? 5 minus 3 is 2. Negative 72 divided by 8. Negative 9x cancels out. Y to the 2nd. So we got the variables right, but if we look at this, we see that we have a 6 and a 9, and both of those can be divided by what? 3. So what I'm going to do is I'm going to divide the 3 out of there. I'm going to have to put it over here. 8x to the third times 3 is 24x to the third. Now I can divide out that remaining 3. So I can do it in stages if I want to. It just gets a little confusing.
Right.
That whatever I divide out over here, I have to multiply in here to increase that, to make that greatest common factor bigger by multiplying it in.
You have to have the lowest on the.
Yeah, these have to be down to where there's nothing that can divide into both of those. Yep. I think you guys are ready to try one. Give that one a shot in your notes. Let's see how you're doing. What'd you get for the greatest common factor for the numbers? 10 is correct. Anybody have any questions on where the 10 came from? Yep. 80 is 22225, and 50 is 255. So they had a 2 and they had a 5. So that's where the 10 comes from. Variables. X to the third.
Y to the second.
Y is not part of the greatest common factor.
No.
We have y to the 7th here, but there is no y over here, so it's y to the 0, or just not there. And z to the 2nd. Good. So 10 x to the 3rd z squared. So 80 divided by 10. 8. X to the 5th divided by x to the 3rd. X to the 2nd. Y to the 7th. There's nothing to do to the y. Z squared divided by z squared cancels out. Negative 50 divided by 10. Negative 5. X cancels out. X to the 3rd divided by x to the 3rd cancels out. And z squared. 4 minus 2 is 2. So z to the 2nd, or z squared. I'm hearing a lot of really small mistakes. It's a matter, there's just a lot of steps to keep track of there and get them all right, isn't it? Well, in order to stay true to myself, I have to do this to you. 30 x to the 5th y squared minus 24 x to the 4th y to the 4th plus 42 x to the 3rd y to the 6th. I need to find the GCF. The process does not change at all. I still find the greatest common factor for the numbers, which means I am still factoring the numbers. 30 is 2 times 3 times 5. 24 is 2 times 2 times 2 times 3. 42 is 2 times 3 times 7. Now, before I go any further, is there anybody who is having troubles with the factor trees and factoring them out that wants to see me go through factoring those? What's that? You're getting better at it? Listen, I'll tell you this, it's a little bit of practice, and that progression I showed you, start with 10, 5, 2, and then 3. And then from there you got to try 7 and 11 if nothing else worked. So here, what is in common?
2, 3.
A 2 and a 3. It has to appear in all 3 of them to be considered in common this time. So 2 times 3 is 6. So 6 is the number of our greatest common factor. How about for x? To the third. It's still the lowest power. We've got 5th, 4th, and 3rd. 3rd is the smallest one. How about y? Squared, or to the 2nd. And now we've got to find out what is left over. So I'm going to come up here, and I'm going to divide by 6x to the 3rd y squared. So 30x to the 5th y squared divided by 6x to the 3rd y squared. 5x to the 2nd. Perfect. Negative 24x to the 4th y to the 4th divided by 6x to the 3rd y squared. Perfect. Negative 24 divided by 6 is negative 4. X to the 4th divided by x to the 3rd is just x. And y to the 4th divided by y squared is y squared. 42x to the 3rd y to the 6th divided by the 6x to the 3rd y squared. Positive 7. Y to the 4th, as you said. I don't know why I made that a different color, but I did. But so there it is. The factoring of the 30x to the 5th y squared minus 24x to the 4th y to the 4th plus 42x to the 3rd y to the 6th. The factoring is 6x to the 3rd y squared times the 5x squared minus 4xy squared plus 7x, or 7y to the 4th. So that's the factoring. I'm going to let you guys try this one in your note. It is 32x to the 7th, y, z to the 3rd, minus 40x to the 5th, y to the 3rd, z, plus 24x to the 3rd, y to the 5th. Factor that, find the greatest common factor, and factor that. Let's see how you're doing. For the numbers, what did you get for the greatest common factor? 8 works. For x?
X to the 3rd.
X to the 3rd. Y? Just y. Z is not part of it. No Z in this one. So we're going to divide this by 8x to the 3rd y. 32 divided by 8. 4, and then for the variables?
X to the 4th.
X to the 4th, yep.
Z to the 3rd.
And z to the 3rd. Good. Y divides out. How about the negative 40 divided by 8? Negative 5. And for the variables?
second,
X
y
is,
to the second, and z.
perfect. X to the second, y to the second, and z. 24 divided by 8. Careful.
Oh,
Three.
sorry.
3. Positive 3. For the variables,
Y to the fourth,
y to the fourth. Good. The x to the third divided by x to the third cancels out. Y to the fifth divided by y is y to the fourth.
Why wasn't z part of the divisible, the 8 to 8?
Because there was no z here.
Oh, okay.
So that made the lowest power of z 0. Yeah, that's why I threw that into a couple of these, because that's a very common mistake. Is unless the variable appears in every term, in every digit, it cannot be part of the GCF. So when we're asked to factor, the first step is always to look for that greatest common factor, the GCF. If there is no greatest common factor, or once we take out the greatest common factor, step 2 depends on how many terms are in the list. If it's a 2-term number, a 2-digit number, we would look for special products. This is something we're not going to get into in this class, but it would be like the difference of perfect squares or the sum or difference of perfect cubes. Like if I have x squared minus y squared, that's the difference of two perfect squares. That equals x plus y times x minus y. That's a special product. It's a very common recurring special product. This is what we call a sum and difference product, by the way. That gives us that difference of perfect squares. If it has 3 terms, we're going to look at reverse multiplication, sometimes called FOIL in reverse. We're going to look at that a lot more in just a second. If it has 4 terms or 4 digits, we would do grouping. Grouping is not something we'll get to in this course, but it involves a combination of the greatest common factor method and then doing the same thing again. We want to take a little bit of a look at this reverse multiplication thing. Up above, we had the problem. X plus 5 times x plus 2. And we did FOIL. We did the first digit, x times x is x squared. That's my f. Then we did the outside. X times 2 was 2x. That's my O. Then we did the inside. 5 times x is 5x. That's my I. Then we did the last. 5 times 2 is 10. That's the L. And we saw that that first digit, the x squared, just stays x squared. These two are almost always combined. 2x and 5x make 7x. That's my outside and inside together. And then the last digit is just the L, the last, the 10. If I want to reverse that multiplication, if I am given a polynomial or an algebraic number that's 3 digits like this, x squared plus 7x plus 10, and I am asked to factor it. First thing I would always do is look for a greatest common factor, but there's no common factors here. Because this coefficient is a 1, so there's no number, and there's no x in this term, so there's no variable. So there is not a common factor here at all. So then we go to that reverse multiplication. And the reverse multiplication, as we saw over here, two two-digit numbers multiply to make that three-digit number. We know that these first two digits, that would be the f, right, have to make this. What two things multiply to make x squared? Yeah, x times x is what that has to be. We know these two digits, the L's, have to multiply to make this last digit. So to multiply to make 10, I've got a choice. I can have 2 times 5 or 1 times 10. Well, we know because we just did this multiplication over here that we know it has to be what? 2 times 5. Now it's a positive 10, so it could either be a positive 2 times a positive 5 or a negative 2 times a negative 5. We know it's positive because we just did it over here. There's another way we can know they have to be positive, and I'm going to show you that in a second. How do I know? The first digit here has to be right. X times x, there's nothing to worry about there. That last digit, though, we said could be 2 times 5, could be a negative 2 times negative 5, or a 1 times 10, or a negative 1 times a negative 10. So how do we know we got those digits right? Well, we check using this digit. This digit is made up of a combination of the outside and the inside. The O and the I over here, right? So what do I have on the outside here? X times 5 is 5x. What do I get on the inside? 2x. 2 times x is 2x. If I add those together, I get 7x. Is that what I wanted up here? Yes, it is. So x plus 2 times x plus 5 is the correct answer. So let's say I have x squared plus 7x plus 12. Are there any common factors? Say no. No, there's not. Because the number on the first one is a 1, and there's no variable in the last digit. So there's no numbers, no variables. So we're going to try the reverse multiplication. Well, we know that first digit, those first digits must multiply to make what? The x squared. So that has to be just x and x. The last digits have to multiply to make 12. Gives us 1 times 12, 2 times 6, or 3 times 4. Or negative 1 times negative 12, and negative 2 times negative 6. I'm going to tell you right now, we can rule out the negative times negative really quickly because this right here is a positive 7. I can't add 2 negatives and get a positive. So I have to use one of those. And the only way I really know for sure which one works is to pick one and test it. So let's pick the 2 and the 6. You're starting to see the pattern already of how we work ahead. Yep. Yeah. X times 6 would be 6x, and 2 times x would be 2x. That adds to make 8x. That's not going to work. And you are absolutely correct. It is the 2 or the 3 and the 4. Now if we double check it, x times 4 is 4x. 3 times x is 3x. That adds up to make 7x. That's what we wanted. So x plus 3 times x plus 4 is the correct answer. So, talk me through this one. Now, don't forget the first step. What's the first step? Always check to see if there is a greatest common factor. Is there one?
No.
No, there isn't. So then, tell me what to do. Okay. We know we've got x times x to make x squared. That's going to take up the first spot in each side. Yep, in each spot. So what about that 24? You got it. We've got 1 times 24, 2 times 12, 3 times 8, 4 times 6. I ignored the negatives because the 25 is a positive. Which one would we use? The 1 and the 24. So plus 1 and plus 24. So you're starting to see already they have to multiply to make 24, but they also have to add to make the 25. If we double check that, it will work out. Now, you guys know me by now. You know this one's coming. Oh, what do I want to put in here? Try this one in your notes. So we had x and x. What would we have for the other numbers? 1 and 8, but it has to be negative 1 and negative 8 because it is negative 9. So we double check it. We've got x times negative 8 is negative 8x. Negative 1 times x is negative 1x, which equals negative 9x. How does that differ from this one? There's a negative in it still, but where's the negative at? It's on the last term. There's still no common factor. The first digit will still be x times x to make x squared. But one of these has to be plus and one has to be minus. Because it's a negative 8. You have to have a positive times a negative. So it's a positive 1 times a negative 8, or a negative 1 times a positive 8. Positive 2 times a negative 4, or a negative 2 times a positive 4. Which one are we going to try?
2 times negative 4.
Positive 2 times negative 4. We're going to do x times negative 4 is negative 4x. Bless you. And 2 times x is 2x. That adds up to be negative 2x. Well, we wanted a positive 2x. But this does tell us something. We're on the right track. We just need to switch them around. Yeah, negative 2 and a positive 4. So now it's a positive 4x, 4 times, or x times 4, and negative 2 times x is a negative 2x. That makes a positive 2x. So that's what we want. So it's x minus 2 times x plus 4. These two problems are very, very similar. They both have the same complication that we haven't had before. Can anybody tell me what it is?
2x plus 3.
Yeah, it's 2x squared, not just x squared. Where did we start on the first one?
The outside x.
What did I just do there? There's a common factor of 2. All the numbers can be divided by 2. So that becomes 2 times x squared plus 4x plus 3. Now, we've taken out the common factor. Does not mean we're done. That 2 is still there. Just like when we factored something like 20. If you factor 20, you might have a 2 and a 10 here. Well, the 2 is prime, but the 10 can still be split up. Same here. This can still be split up. X times x to make x squared. Well, 3 is pretty easy, right? 1 and 3 to make 3. Does that give us the 4x?
Yeah.
Yes, it does. This one looks very similar, but can I divide it by a 2? No. Can I divide it by any common factor? No. So I'm not going to have x and x anymore. I have to have 2x times x to make 2x squared. Six is going to be 1 times 6, or 2 times 3. Now, 1 times 6 looks really attractive to us because 1 times 6 is 6, and 1 plus 6 is 7. However, we got that 2 up there. If I try 1 and 6, is it going to work? Well, 2x times 6 is 12x. 1 times x is 1x, that's 13x. Is that what we wanted? No, we wanted 7x. Now, since this is a 2x and an x, it does make a difference if I switch their spots. Now on the outside, 2x times 1 is 2x, 6 times x, 6x, that adds up to 8x. Not what I wanted, right? You could have known from the start that this wouldn't work because 2x plus 6, I would have been able to divide out a 2. Well, I can't. If I can divide a 2 out of here, I would have had to have divided a 2 out of here. So that can't work. So it has to be the 2 and the 3. Let's try it. 2x times 3 is 6x. 2 times x is 2x. That equals 8x. Not what we want. Again, we could have saw that because 2x and 2 could both divide by 2. Couldn't have worked. But since it's a 2x and an x, we have to try to switch their spots. 2x plus 2, or 2x times 2, 4x, and 3 times x, 3x, which is 7x. I talked before about seeing patterns, and this is one of those spots where it's seeing patterns is very, very helpful. Because you start seeing, okay, these two and 3 have to multiply to make 6. Double this one plus this one have to add to make 7. So you've got to start thinking about it. You know, this one's double because it's going to be the 2x up here. It's called combinatorial thinking. Now, I'm not going to spend any more time on this because we're not going to do a lot of this FOIL in reverse or reverse multiplication in this class. If you were to go on to a 4-year degree and take a college algebra course, you would do a ton of this because it's required for solving certain types of equations. It's called the quadratic equations. And I'll show you an example of what I mean. Well, Robin, you're sitting here, so we're going to have some fun with Robin. Let's say Robin did not do his homework. So, I'm going to take a cannon. Now, I know I drew the cannon kind of funny. The top of the barrel of the cannon is at the surface of the ground. In order to make this equation work, to keep a simple equation, I have to do that. We're loading Robin in a cannon, and we are shooting him into the air as punishment for not having his homework done. We are going to shoot him into the air with an initial velocity of 80 feet per second. The formula for the height of someone fired out of a cannon is their initial velocity times the time that they've been in the air minus 16 feet per second. That's the acceleration of gravity times their time squared. I want to know how long is it before Robin splats back down on the ground. Splat might be the key term there, by the way. Well, what height is he going to be at when he hits the ground? Yeah, all true. We're assuming we put a safety pad underneath you to get you. We want to put on a show. Yeah. When he hits the ground, he's going to be at a height of 0. His initial velocity was 80. And the rest of it's there. So to solve this, we would factor. First thing is to solve a quadratic, it has to be equal to 0 on one side. And it is here. That's why I put the barrel of the cannon at 0. Yeah. Next, we have to factor. I'm going to slide this down a little bit so I'm not in the middle of that line. 80t and 16t squared have a greatest common factor of 16t. 80 divided by 16 is 5. T divided by t divides out. Negative 16 divided by 16 is a negative 1. T squared divided by t is just t. When we have an equation like this, the zero product rule takes over. We talked about this in the first week a little bit. The zero product rule states that anything times 0 equals 0. That's part of it. There's a more powerful version of the zero product rule that says if two things multiply to make 0, if A times B equals 0, either A is 0 or B is 0 or both are 0. So now that I have this factored, I can say if that equals 0, either 16t equals 0 or 5 minus 1t is just 5 minus t equals 0. I'll leave the minus 1 on there. It makes it easier, actually. So solving this first one, I just divide by 16. Well, what's 0 divided by 16? 0. That makes sense. You were at the ground when the cannon fired. At 0 seconds, you were at the ground. Over here, I'm going to subtract 5. Negative 1t equals negative 5. Then I'm going to divide by the negative 1. T equals 5. He will come back down to the ground at 5 seconds. So, from ignition, you got 5 seconds to figure out how to land softly. Make yourself big to the wind. Of course, this does all ignore wind resistance too, by the way. That's just an example of how this factoring is used in solving equations. That comes up a lot in engineering. In business, for maximizing or minimizing situations, that comes up a lot in business. Okay. Well, we're not going to be solving a lot of quadratic equations, but we are going to be solving equations like we've already seen that look like this. What do we have to do there? Well, we see parentheses, it should always scream at us, do something here first. Anything to do inside the parentheses?
No.
Nope. So we're going to multiply by the 8. Good. 8 times 2x? 16x. 8 times negative 7? Negative 56 equals the 24 still. Then what?
56.
Add 56. 16x equals 80, and then
Divide by 16.
divide by 16. Good. X equals 5. And of course, we could go back up here, replace x with 5, and verify that it works out. And it does. Now, some people have asked, why can't I just divide out the 8 here and get 2x minus 7 equals 3? And this equation, that would work, but the reason I don't show you that is it doesn't always work. Because I might give you an equation like this. I can't divide this by 5. It doesn't work. It does work, but I have to be very, very careful. So I see the parentheses. There's nothing to do in the parentheses, so I'm going to multiply by 5. 5 times 7x, 35x. 5 times negative 4, negative 20, and then plus 5 is 90. And then I'm going to combine. Yep, negative 20 and positive 5 make
Negative 20 plus 5. Negative 15.
negative 15. Sorry about that. Excuse me. And then
Add 15.
add the 15. 35x equals 105. And then divide by 35. X equals 3. And again, you could go back up here and you could replace x with 3 and make sure it comes out to be the same thing on both sides. I'm going to have you guys try this one in your notes. 5 times 3x plus 1 plus 2x equals 56. Give that one a shot. So where do we start? Multiply it. There's nothing to do inside, so we're going to multiply. What do we get?
15x plus 5.
15x plus 5. Good. And then? So plus 2x equals 56. And then
15x and 2x.
which makes 17x, and then equals 56. And then subtract the 5. 17x is 51, and then divide by 17. X equals 3. Cool. And of course, you could go back and double check that one. Looking at this one, it's very easy to miss what needs to be done here. We've talked a lot about ones. Like there's a 1 here even though we don't write it. That's x to the power of 1. Or 5x to the power of 1 there. Or if we just have an x or a y, that's really 1x or 1y. Where is the missing 1 in this problem? It's in front of the parentheses. Whenever you have a minus in front of a parentheses like that, it should be a -1 times the parentheses. So here we're going to keep the 2x. Then we're going to multiply the parentheses by the -1, which is going to give us you got it. -1 times 5x is -5x. -1 times +1 is a -1. That's usually the part that most people miss. They get the negative on the 5x, but they forget the negative on the 1. Then what? 2x and -5x make -3x. Still have the -1. And then add 1. -3x equals 15. And then divide by -3. So x equals a -5 here. Time to let you guys try one. Give that one a shot. You ready, or we need another minute? Take a look. Okay. First, we're going to start with the first one here. Nothing to do inside either parentheses. So we're going to do the multiplying them. So 2 times 5x, 10x, and 2 times the negative 4. Negative 8. What do we have to do over here? It's a negative 1, yes. Negative 1 times 3x. Negative 3x, and a negative 1 times 2. Negative 2. And that all still equals 4. And then we combine the x's. 10 and negative 3 make 7x. Minus 10, negative 8, negative 2 make negative 10, so minus 10 equals 4. And then what? We add 10. 7x equals 14, and then divide by 7. X equals 2. Well, since we're having so much fun. Notice I started on the very left-hand side of my page. We are going to start our break right now. And we're going to come back at 10:25. And when you come back, I want you to work on this problem.